Hello and welcome to our second video on concepts of probability. Let's move on and talk about the statistical test assumptions. And so first of all, I want to go back to our picture that we've been working on. And I want to ask the question, here we have our sampling distribution of the means, and we know a few things about it. We know that it's narrower than the overlying population distribution. We know that it's centered on the mean, and we also know based on the central limit theorem that if our sample size is big enough that it will be normally distributed. So let's expand that concept just a little bit. So here we have our sampling distribution of the mean, and what if instead of having this assumption that it's normally distributed, what if it wasn't? What if instead of that, and I'm not going to make this a dashed line, but I'm just going to kind of like, what if instead it was kind of more like this? What if it was skewed to the right? The downside to that is that we need, in order for our interpretation of the test that we're running, in order to test whether this x bar is unusual or not, we need that to be centered on mu and for it to be normally distributed. In other words, if it's skewed to the right or to the left, it will include different x bars depending on where the skew is. And so we need that to be normally distributed and not to be out of line. So I'm going to erase that line because it's distracting. So let's go back over here to the statistical test assumptions. And I like to call this section required ingredients. In other words, if we put the wrong ingredients in, we might get the wrong results. And so think about baking. What if you're baking a cake and you're like, oh, I don't have any flour. I don't know what to do. I know. I have something that's white in the cupboard. Instead of flour, I'll just use sugar. And so you make this cake and it's made out of sugar. You put it in the oven and it doesn't rise. It doesn't turn out right. And so if we put the wrong ingredients in, we're going to end up with the wrong results. In other words, if the assumptions for that specific test are not met, then our interpretation of the results might be wrong. It depends how far away from the assumptions being met they are. But we want to be able to depend on the results to tell us the right thing. And so the assumption for this particular test that we're doing right now is called normality. And so our one assumption is that the sampling distribution of the means needs to be normally distributed. And that's this black curve right here. And we already learned that that will be true as long as we have a large enough sample size. So let's go back up here and remind ourselves that sample size is important. And so this will be true if we have a large enough sample size. So if n is greater than or equal to approximately 30, based on the central limit theorem, this assumption will be true. There's another situation where that assumption will be true, and that's if the underlying population distribution is normally distributed, regardless of the size. And so if the population distribution is normal, then this will also be a correct assumption. Now, remember how we said we don't have the population distribution. The only thing we have is the sample distribution. So, but we also learned that the shape of the sample distribution often mimics the shape of the population distribution. Now, the problem with this is that when you have really small numbers, which is when this central limit theorem doesn't hold, then your sample distribution can also look pretty funky. If you only have a sample of, say, size 6 or 8, then it might be hard to tell that the sample distribution is normal or not. So essentially, the main thing that we look for in order for this assumption to be true is that our sample size is 30 or more. Now, if you're really convinced that the sample is normally distributed, then we can also assume that the population is normally distributed and go with that as our statistical assumption. Now, the interesting thing is that statistical test assumptions are actually pretty robust. And I'm going to just write that here, robust. And by robust, what we mean by that is it's resilient against minor deviations from the assumptions being correct. So you might look at a normal curve and say, well, it's not perfectly normal, or there's a tiny bit of skew, or even a medium amount of skew. And our statistical tests that we run are actually pretty good, even if the assumptions are violated not in a terribly severe way. If, on the other hand, you have severe skew in your sample, this shape right here, then what that means is that you may need to depend on the central limit theorem in order to validate that this assumption is met. So that concludes our video on statistical test assumptions. In the future, we'll learn more assumptions with other statistical tests, but that's all we're going to do for now.